Hello everyone, Simeon Gabriel. Welcome to my data analytics course with Python and machine learning. And today we'll be looking at machine learning. And what we have here, we say machine learning is the ability of machine to predict outcomes without being explicitly programmed to do so. And we see it is about creating and implementing algorithms that lets machine receive data and use the data, make predictions from the data we've collected, and we analyze the patterns of what our data will give us. Now we'll give recommendations. Machine learning is all about creating algorithm that let machine receive data and helps it to perform calculation and also apply statistical method to make predictions with unprecedented accuracy. Now we look at the next. Now we have different type of machine learning. We have the supervised learning, we have the unsupervised learning, and we have the reinforcement learning. Now looking at the supervised learning is a type of machine learning where an algorithm learns from the labeled trained data, okay, like just like a historical data that you've already collected and use it to make predictions and decisions. Now lastly, we're going to be looking at unsupervised learning at the course of this program. You see that unsupervised learning is a category of machine learning where the algorithm is actually trained on data without explicit supervision. Now in this case, we don't have to get a target. It doesn't require a label or target value. Instead, the algorithm identifies patterns, structures, and relationship within the data on its own. Like for instance, we have maybe we have people shopping in the mall, and there are people that buy costly things. There are people that just shop a little. Now you see, we can group them by their behavior. Okay, so this is what unsupervised learning does. So the primary goal of unsupervised learning is to discover hidden insights or group similar data points without guidance. So we'll be looking fully at the coding part of it as we stay tuned as we proceed. Hi everyone, Simeon Gabriel. In this tutorial I'll be looking at machine learning, how we can do machine learning with Python. Now starting with, we have to import our required libraries, and I've imported my libraries here, so I'll be telling you what each of them means. Okay, now first of all, we imported numpy as MP. Now this library is used to work with ND arrays. Okay, now trying to work with a large mathematical data set. All right, now these import pandas here as PD. Now import pandas is the main library for data analysis, and it helps you to wrangle your data, manipulate your data, and also clean your data. Now we also have import matplotlib.pyplot as PLT. Now these are the standards that we use in importing these libraries. Now this as MP, I said here, is an alias. Okay, now you can write anything, but the standard here is MP. Same thing goes for pandas. You see, as PD, this is also an alias, and this is the standard way of writing the alias, but you can write anything, you can represent it with anything. Now we'll talk about the matplotlib pyplot as PLT. Now this is also the standard. Now what we do with this matplotlib library is we use it for data visualization, how to put on interactive visuals of our data set. Okay, now we also have import warnings here. Now when you're working with a Jupyter notebook, there are some warnings it throws to us concerning duplicated codes. Okay, so I think to avoid these warnings from coming up, so I do import warnings dot filter warnings ignore. Okay, we are ignoring those warnings. All right, now we run this. Our required library has been properly imported. It didn't throw us an error, so now we have a load the data set. Okay, here I have to load my data set, the data set I want to work with. So I give it a variable name called df. Okay, in this place, this variable name, you can give it whatever name you feel like giving it. Okay, so I just want to give it df. All right, now in importing or loading a data set, what we do is we do PD, which is the pandas library. So it's an alias, a representation of the pandas library. Instead of writing pandas, so we say as PD, we write it as PD, just like a nickname given to pandas. Okay, so in place of pandas we write PD. So that's the standard. So I say pd dot read csv. Okay, this is how to read. This is a csv file I want to import, so I'm writing the pd dot read csv function. Okay, so this read csv function helps us to load a csv file. Now if it is an html file, I want to load, I'll write underscore html. Okay, if I want to load any other dataset, whether Excel or whatever, so I'll load it using the extension. All right, now we'll run this. Okay, so it has been successfully loaded. It didn't throw us an error. So what we'll do next is we will view 5 rows of the data set, 5 observation of the data set. Okay, now how do we do this? We'll now call the variable name, which I've given it here, to be df. Okay, this df now is the variable name. That's is like the container now holding this value pd dot read underscore csv. Okay, now in viewing a particular observation of the data set, what we have to do is we'll use the head function. Okay, now we say df dot head. Okay, now you can see now this thing by default, this head function gives us 5 observation, that is 5 rows of the data set. But if I want to give a particular observation to be displayed, I will have to indicate it inside the parentheses. Okay, maybe I want okay, let's run it by default. Let's see the default. You can see 5 rows from 0 to 4. Okay, now right, now let me do this. Let me write 10. Okay, let's put 10 there and run it. Now you can see that we're having from 0 to 9. Okay, 0 to 9, you can see from here. So you can see that whichever way you want your data set to be viewed, you can do that. So that is that. Let's just leave it by default. Okay, now we've done that. There's another function also called df dot tail function. Okay, the tail function, what it does, it gives us 5 observation. By default it gives us 5 observation from below the data set. Okay, so you can see it. So let's move further now. Okay, I have to run this so that we can see. You can also customize the number of observation you want to be outputted. All right, now we'll move to exploratory data analysis, which we'll call the EDA analysis. All right, now we have to explore our data, look at the characteristics of our data, go through our data, look at the features of our data. And first of all, one of the things we do, we view the shape. Okay, now viewing the shape of a particular data set which you have loaded, now you place the variable name first, then you do the dot shape. Okay, the shape is an attribute. Okay, it's an attribute in pandas library. All right, so when you do that, you view the shape. Now you see a tuple. Okay, let's run this. You see tuple is being imputed. Okay, so we have 32,5 here. Now what does this mean? 32 meaning it has 32 rows and it has 5 columns. Now if we go to the data set, if we move to the data set back, you will find out that these columns are 5, so it has 32 rows. So we cannot output that 32 rows for now all at once. So just know that this is the shape of a data set. All right, what next? What do we do next? Now we view the type. Okay, now we are going to view the type. What type is this thing loaded? Okay, now represented by as df. All right, now we will look at what is the type. Okay, now we found out that it's a pandas library, it's a core, it's a data frame. Okay, so this data set we loaded is a data frame. All right, the data frame is a multi-dimensional data structure in pandas. Okay, one of the multi-dimensional data structures in pandas. In pandas we have I think 4 data structures. Okay, we have the series, we have the data frame, we have the panel, and we have the panel 4D. So I think the most common ones we see is the series and data frame. All right, so this thing we loaded, okay, is actually a data frame. All right, so we've seen that, we've run it. So the next thing we do is we have to check the entries of a particular columns. Now in a data set, if you want to check a particular column, what are the entries, what are the responses of that column? What you have to do is you place your variable name which you use in loading the data set, which I have here as df. All right, now I just have to pick one of the columns, which is max pause. Okay, so I can use whatever column. Okay, if I want to view the unique entries of a particular column, I can. But let's use this as an example to show you if you are new to data science. So now I will have to specify a particular column in the square bracket. Okay, the column in which I wish to see the unique entries. Okay, then you just do outside the square bracket, you do the dot unique. Okay, is you are applying the unique functions to see every entries, every responses in that particular column. Okay, that's what we use the unique function for. All right, now you can see if I run this, you will see these are the unique function, the unique entries, okay, in the particular column. Okay, so I can even check, for duration as well, so don't be confused. So okay, you can see the unique entry for duration is just 60, 45, 450, and 30. These are just the entries in that particular column. Now we move further. Now the next thing we do is we can also do some descriptive analysis on it. Now we can do some statistical, we can apply some statistical function to our data set. We want to find the mean of the data set. Yeah, this is what we did. Finding the mean of the data set, you just apply the mean function to the data set variable we loaded. Okay, so now not to forget, please just remember that whenever you're applying a function to a particular variable or container, okay, you have to use the dot. Okay, that is, you are trying to apply that particular function on that variable or whatever container it is. So that is why we are putting this dot. That is how functions are being applied in Python. Okay, so we'll run this. So it will give us the mean of the columns having numeric values. Okay, so that's what it will give us. So now if we are having categorical columns there, what it does, it ignores it. Okay, or sometimes it may throw an error. So now since all our columns are having numeric values, then you see this is the duration. This is the mean, the average of the duration column, everything there. And this also in the post column, this is the average, like that, apply to all of them. Okay, so now after doing that, we can also do similar thing, okay, by applying the median function to check for the median value. Okay, so I think we have applied it and this is what we got. All right, now having done that, we have to move to the next. Now you can also do you can also analyze the descriptive statistics of your data set. Okay, by analyzing the descriptive statistics of a particular data set, what you have to do is to apply the describe function. Okay, you say df.describe. all right, you can see I apply it df, which is my variable name. I just say dot describe function. I apply to it. Now you can see we have the count. You can see these are the entire number of values we have in the duration column. Okay, so the number of entries 32, Same thing for pause, same thing for max pause, same thing for calories. All right, you can see that. Now we look at the means. Okay, if we go up, we'll find out that the means is the same thing with the one we actually applied here manually. Okay, now you can see you can also get your mean from this place, your standard deviation, how widely spread your values are, and the minimum values of each columns, the 25% percentile of each column, the 50% percentile of each column, 75% percentile of each column. Now we got the max value, that's the maximum values of each column. Okay, now we have to move. If you want to view your columns, this is how you view your columns. You just apply the dot, the column attribute. Okay, as simple as that. You view everything. Okay, I think we didn't run this. Okay, so to show you. Okay, now let's run this. We'll see the entire. Once you do that, once you apply the column, okay, to any variable name of the data set you loaded, it will give you the entire columns in that data set. Okay, all right. So now there's something we normally check in when doing. Okay, I think we have to ignore this. We have to ignore this for now. Maybe I will still come back to this. I'll still come back to this. Okay, so we'll come back to that. Now we do the data wrangling. All right, now what does data wrangling actually mean? Data wrangling is a process whereby you gather your data, you process it, you analyze it, you figure out the things that are in the data. You understand? You gather information about the data so that you can be able to do an in-depth analysis. All right, now we have to check some things in this data. Okay, normally data wrangling takes 75% of a data scientist time, okay, or a data analyst time. So you have to wrangle your data. All right, it's a kind of manipulation and the rest. So we check for, one of the things we'll do first, we check for null values. Now null values, these are values that has not been entered. Okay, that particular field is empty. All right, so we check for null values, missing values, we can call that. So checking for null values, one of the ways we check for null values in a data set is by applying the isNow function dot any. Okay, what this will give us is it will throw us boolean value. Okay, and boolean value has two values. Okay, the boolean data type has two values, which are the true and the false. Okay, so this particular code is going to throw us either of the true or false in each of the column. Okay, now you can see we have false here. If we have false on a particular column, it means that that column doesn't have a null value. So what this code is trying to say is null value. Okay, then any null value. Okay, good. Now we have duration false, means there's no null value there. There are no null value. Then the date having true means there are null values there. Pause having false, there are no null values there. Mass pause having false, there are no null value there. Then we have calories, which is true. Okay, so which means that there are no values in calories. So we move on. So we can also check for null values in another way again. Now checking for null values, this is another way of checking for null values. Now what this will give us is, okay, I think we have to run this first, then run this. Okay, now good, you see that. So now I said another way of running null values is by using the isNull dot sum. Okay, now this gives you the total sum of null values in a particular column. So this returns an integer, okay, a numeric data type. Okay, now you see we have 0 null values in duration, we have 1. Okay, under pause we have 0, under max we have 0, then under calories we have just 2 null values there. So we can also run this to check it. All right, now what this does here is we have print df dot to underscore string function. Okay, now what this will do for us, it will print the entire data set. Okay, it will print the entire data set that we have. Now you find out that when you just run, okay, let's try something. If you just say df, we just call df, which is the variable holding the data set. If you want to display that particular data set, now you can see, okay, if this is actually a data set having very large values, all you have is, you will see it will not output everything. So it will not output everything actually. So let's take this off. So another way of getting everything entirely out is by using the to underscore string function. Okay, when you do the print, then you write your variable name here, then you do the dot to string. All right, so that is how to view everything. All right, now we can also, okay, let's see, I think I can run it. All right, now we actually have checked for null values, and we'll be seeing later how we can also remove these null values, but there are irregularities in our data. We also have under irregularities which is duplicated values. When you have duplicated values, you have to get rid of them, okay, so that your data can be neat and clean for data analysis, okay, and also used for prediction as well, so that you can get the right prediction and the right model evaluation for a particular algorithm or model that is being applied to that data set to predict what will be the outcome. Okay, so now we will check for duplicated values. You see how we can check for duplicated values. You write the print, then the variable holding your data set, which I have here, df dot duplicated. Okay, you can see duplicated function. So checking for whether the values, whether they are duplicated values. Now if they are duplicated values, it will show you true, but if they are not, it will show you false. So it's returning either of the boolean value, true or false. All right, on every row you can see here, we have it here, you can see, okay, we have false here, you can see we have true here. That means the duplicated value in this row 12. Okay, well, let's look up at the data set. I think row 12. Okay, now we can see this is row 12, this is row 12. Okay, so you can see above it, row 11 has the same data set with row 12, but since row 11 came before row 12, so row 12 will be seen as a duplicated value of 11. Okay, so that is why it is showing true for only 12, because the 11 has already come first. So having 12 means is duplicating what has already been there. So we will see how we can get rid of these duplicates. Okay, so now one of the ways to get rid of these duplicate values is to apply the drop duplicate. Okay, let's run this. Okay, so one of the ways to apply these duplicate values, to remove these duplicate rows, is to actually use the drop underscore duplicate. You can see it here. All right, now we use the in place is equal to true. That means it will not return a new data frame. Okay, so if I run this now, that duplicate value will be erased. All right, but the data set will still remain, the data frame will still remain as it is. There will be no new data frame that will be returned. Okay, so let's run it to see. So I want to run to do the to string to see my data set, because I have applied the drop duplicate here. you can see it. So let's see how this can be done. Now we've done that. Let's see for 12. You can see we don't have row 12 again. All right, it has been removed. So that's how to remove duplicate values. All right, then we will see, we already saw how we could identify or check for null values in our data set. Now we can handle these null values or missing values. Okay, now there are various ways of handling these missing values. All right, depending on what you want. All right, so we can apply, we can drop the entire null values or missing values in our data set. Now you have to be careful concerning this, because if you have large number of missing values, dropping it will most times be a problem. But since in this case, let's return back to where we checked for null values. Okay, now you can see that this place where it returned numeric, that is integers, for each columns for the null values in it. And you can see that we don't have much null values. In total, we just have 3 null values, 1 from the date column, 2 from the calories. Okay, now what we do, we have to drop it because they are not much and it will not have any effect on our data set. Okay, so you can see here I have to give it a name, df underscore drop, okay, which is equals to, it's a variable name holding this particular operation I want to do. So don't get confused. I can write df, which is the data, the variable to the data set, and it will carry out this operation and remain where it is. Okay, so I want to show you that carrying out this operation, I give it a new variable name. This operation has a variable name, df underscore drop. Okay, so that I can be able to identify it. Now df, which is my data, the variable of my data set I loaded, I'll just say dot drop now. This is how to drop null values in a data set, the drop now function. So if I run it, okay, then I think what I have to have, okay, now we have to check for the shape, okay, to see if these null values were actually removed. Okay, if I run this, let's move up a little. Now you can see that the shape of the data set has been actually changed, okay, has been altered. So you see the shape now is 28,5, whereas we have when we checked at first the shape, we're having 32,5, 32 rows. Now the rows has been reduced to 28 because of the null values we removed. Okay, now you can see these things are effective. You have to always check it to know, to be sure that it has been done away with. So you can see I run it, so 28,5. So we can also okay, 2,5. So let's spend this. So now there are things we can also do to this. Okay, I think we can also, let's check say print, let's check the entire data set as well, since we've checked the shape. So we can say df underscore drop, dot to string, okay. So we run it, and you see that there are no null values. Again, we dropped all the null values. Now why am I applying this to string to this df underscore drop? Because this is what is having operation I did on the data set. It's no longer df but df underscore drop. Okay, so if we just write a df, which we used in loading our data set before, you find out that it's still having null values. Okay, let's look at it. I think most people get confused at this point. You can see the operation I carried out, I gave it a new variable name, df underscore drop. That is why you can see me applying the df here. You can still see null values, but okay, we can still use that for other things. Can still use it for other things. Now there's another way to apply null values, okay, which is called the fill now function. All right, so we can also apply the fill now function to any data set having null values. How do we do that? Okay, what does this do actually? The fill now actually fills the place we're having null values in our data set. It fills it with the particular entry we write on inside the parentheses of the fill now function. Okay, so now you can, in applying the fill now function, you can do whatever you want to do. So let's see, I think, let me write in place is equals to, let's say, true. Okay, so with the fill now function, you write whatever you want to fill it with here. So let me just write missing values. Okay, so what will happen is every place that there's a null value in our data set, you will see missing values there, and it will not return a new data frame. All right, so let's run this. Okay, it's saying missing values is not defined. So let's see. Let me see. Okay, what will happen is, let's just replace it with an integer. Let's just replace it with an integer. Let me say 100, or let's say 140, or let me give it 130. Okay, so if I run this, you can see it has been applied. We have been able to insert 130 to every place there are no values. So we can also check for that. So we say below, so we say df dot to string. Okay, let's apply the print. Let's apply the print function. So we have this. Okay, so let's check from this data set. I think line 22 has no values. You can see line 18 has no values here, line 28 has no value here. So let's check it. Let's check and see, because I already ran this. So let's see, line 18, 22, 28, line 18. You see the null value has been replaced with 130. You can see it here. Okay, line 22 has been replaced with 130 here. The next one is line 28. Okay, it has been replaced with 130 here. So you can see you can replace the null value with anything you want using the fill now function. Okay, now another thing we can also do, you can also drop for a particular column. Okay, you can also drop null values. If you don't want to drop for the entire column, you can also drop for a particular column. Okay, that can be done effectively. Okay, so you can just write the df dot drop. Okay, all right, now this function actually, this helps us to drop a particular column. Okay, it helps us to drop a particular column, not the null values in the particular column. If I want to drop a particular column, I can just do the drop function, then I'll specify that particular column. If we do that, you see we'll drop this particular column called date. So let's run it and see. Then let's output. let's say df dot head. So you can see the date column is no longer here. All right, so this is how to drop a particular column. So I want to go and I want to run my data back. I want to run this back so that I can still have those null values. Okay, because I want to apply something to it. So now let's see. Okay, now there's another way of replacing null values or missing values with a particular statistical function. Okay, now I think this is a machine learning way of applying it. All right, so you can replace null values or missing values with statistical function like mean, median, and mode. Okay, now in doing that, first of all, what you have to do, you have to import a simple imputer from sklearn. Okay, and sklearn here is a machine learning library. Okay, now first of all, what you have to do, you say from sklearn. Now from sklearn, meaning from sklearn is the family name. Okay, then you say dot impute. This impute here is a submodule. Okay, it's a submodule under the sklearn that helps us to replace null values or missing values in a data set using machine learning library. Okay, now you see from this sklearn family dot this impute module under the sk family. So we will import the simple imputer. Okay, that's what we call simple imputer. Okay, that's what will help us. All right, now to replace our missing value. So now we say I've given the variable name called mean imputer. Okay, you can give it whatever variable name you wish to give it. All right, so I'm just giving it mean imputer so that it will reflect what I want to do on this particular line. Okay, now we will call the simple imputer function. Okay, inside the simple imputer function, you can see it here, there are parameters that I need. Now one of the parameter is missing underscore values. Okay, so within the numpy library, or even in the pandas, I think this is numpy library actually. If you want to create a null value, or the way to represent null values also is by saying np.nan. I think this is a numpy library function. Okay, so you just put np.nan, it will return a null value. So we are saying that the missing values we are looking for is np.nan, which will be which is null value. Okay, so now the strategy we apply. This is another parameter, the strategy. You can apply any strategy. You can apply the mean, you can apply the median, you can apply the mode. In applying the mode, we use the most underscore frequent. Okay, that's to apply okay, let's apply mean on this. Let's apply the mean. This is a strategy. We want to use the mean value of each column to represent null values in every column. Okay, so every column will take its mean to replace its own null value. So that's what we mean here. This is the strategy mean. You can use median, you can use mode, which is most underscore frequent. So in this case, we are using mean. So what you have to do next is you have to call the variable name you used in holding this particular statement. All right, now you see that seeing that our data set that we loaded is having a name called df. Okay, that's the variable name, so we have to fit it into this simple imputer. Okay, simple imputer function, we have to fit it into it. So that's why I'm having df here. So you see, then we use the mean imputer dot transform with the transform function. Now why I'm having dot values here, don't worry, This is just saying that the values in every value in this, if I run it, so we're still waiting for it to load. It's still loading. Well, it's showing us an error. So what's the problem? Okay, it said cannot use main strategy with non-numeric data, could not convert string to float. Okay, now I think that is because we are having a date column. I think let's I ran this back again. I ran the df so that we can be able to apply the stuff on it. So we are still having the date column. Still having the date column. You can see it here. So I told you there's a way in dropping. So we have to drop the date column. Okay, so what we have to do, you say df dot drop, then you specify the column, so we write the date. Okay, so we can apply it here. So I'm using df because I still want to maintain my variable name. So let's check if we have dropped the date column. Dot head. Okay, the date column has been dropped, so we can apply this now. Okay, now you see, when applying machine learning libraries or apply machine learning functions here, machine learning functions only work with float data type and integer data type. There are some cases where we have to encode a categorical data. Okay, so that is what happened here. That is a date data type. Okay, so we had to eliminate it. Okay, so because machine learning libraries doesn't identify it, so you can see the mean has been applied. Okay, if we go back, you can see the mean has been applied here. That was the mean for our data set that has been applied. I think here also that has been applied. Every column will replace its mean to any place it's having a null value in its own column. So that is that. All right, we're going to be looking at how to check for outliers also. I think that is another irregularity in our data. All right, we're going to check for outliers, and when we talk about outliers are values. These are values that lies outside the usual observation of values. Okay, so it is good for us to get out the outliers. Okay, so now I have my code here, which is for column in df. You see plt.figure df dot. Now we are looping through our data set. Okay, we'll be bringing out the figures. That's why we're having here we'll be looping through our data set called df. So we say plt.figure. That means we have to bring out every column. Will bring out the figure of every column, and it will appear in a box plot. Okay, so all right, let me run this and see. All right, I think we have this, and you can see for okay, see, this is duration, this is pause, having one outlier, these two, this none. Okay, what I'll do now is I'll show you how to get rid of outliers. Okay, now let's pick this pause. Okay, the pause column, you can see the outliers, so let's pick the pause, that of the pause column. Now what we have to do, you can just say there's another way to check it. As you can see, import cborn as SNS. Okay, then you say sns dot box plot then this, then I say df okay. Let's say since I'm picking a particular column, let me just say pause. So I just want to show us how we can get rid of. Okay, now you can see this is an outlier here, there's an outlier here. So how do we handle that? All right, let me get this down. Okay, to handle our outliers, now there are a few things to do. We have to create a filter based on the box plot obtained, okay, and we'll apply the filter to the data frame. All right, so let me say let me call this filter data. Filter data is equals to let's say df. Since I'm trying to work on the outliers of the pause column, so I just have to use the pause in this case. So I'll say dot values. Okay, now we can see that from the box plot here we have here for pause, for the box plot we have here, you find out that this outlier is almost 130. Okay, 130. So you can see it's at the point of 130. So we will now say that we are only taking the values of 125 that are less than 125 or that are less than 130, so that this outlier will not enter. Okay, so let's say we are taking the okay, so let's see okay, values I think it should be that are less than 130. Okay, that less than 130, I think that will be okay, or let's say that less than 125. All right, so we bring this down. Now I can say, let me say df1. Okay, let me just say df outlier. I think this one will do. Df outlier, then I'll say equals to let's say df what do I give this now? Let's say filter data, because I'm trying to use this. Okay, so df filter data. Okay, so what I'll do now here, I will just have to call it, so df outlier that I've created, df outlier. So if I run this now, let's see what it will give to us. Okay, so you can see this is the outlier. Okay, so I believe okay, sorry, this is supposed to be that are greater. Okay, sorry, we messed it up. So okay, now these are the relevant values we'll be using. Now you can find out that the values that are greater than 125 is just the outlier that was there. Okay, you can see just the outlier. So now we can just want to make use of the relevant observations that are not outside the box. So you say less than, that are less than, so you can see it here that the values that is good to go. Okay, so I think that is that for outliers. And okay, we'll be looking at regression in our next video. Thank you.